We bought two identical EcoBoost F-150s, put them on the same routes, the same loads, and the same maintenance schedule, and ran one on regular and one on premium for 200,000 miles. Everyone has an opinion about which fuel your EcoBoost actually needs. Ford's own manual gives you a confusing answer, so we stopped guessing and just drove the trucks until something broke, wore out, or proved itself. What we found surprised even me, and I have been wrenching on these engines for over 15 years. Let's talk about how this test actually started, because the setup matters more than people realize. We picked two 2018 F-150s, both with the 3.5-liter EcoBoost V6, both crew cab, both four-wheel drive, both off the same production run, within a few weeks of each other. Same tires, same gear ratio, same tow package. Truck A ran on 87 octane regular for its entire life. Truck B ran on 93 octane premium for its entire life. Everything else stayed identical. Same driver rotation, same routes mixing highway and city, same towing schedule, pulling a 6,000-pound trailer twice a month, same oil changes on the same interval, same technician doing every inspection. The goal wasn't to prove a theory, the goal was to remove every variable except the one thing we actually wanted to test. Here's the first thing you need to understand about EcoBoost engines before any of these numbers make sense. These are turbocharged direct injection engines, and Ford engineered them with something called a knock sensor system that constantly monitors combustion inside each cylinder. When the engine detects knock, which is essentially fuel igniting too early or too violently for the current ignition timing, the computer automatically pulls timing back to protect the engine. Lower octane fuel is more prone to that early ignition under high cylinder pressure, especially when the turbo is building boost. So in theory, the engine should just adapt on the fly and keep running safely regardless of which fuel you put in it. Ford designed it that way on purpose because they wanted these trucks to run on regular gas for buyers who prioritize cost, while still allowing premium for buyers who wanted maximum output. That is the official position. Our job was to find out what actually happens to the engine over 200,000 real miles of that adaptation happening constantly. The first noticeable difference showed up almost immediately, and it wasn't wear related at all. It was power. Truck B, running premium, consistently pulled harder under load, not in a dramatic way you'd notice during normal driving, but the moment we loaded the trailer and asked for full throttle merging onto the highway, Truck B responded a half-second faster and held boost more consistently. We logged this with a scan tool plugged into both trucks during identical merge tests, and the data backed up what the drivers were feeling. On premium, the engine held closer to its maximum commanded boost pressure and advanced the timing further before the knock sensor intervened. On regular, especially under sustained heavy load and summer heat, the computer pulled timing more aggressively and dropped boost slightly to stay safe. The difference in raw horsepower under those specific towing conditions worked out to roughly 5 to 8% less peak output on regular fuel. Under normal unloaded driving, the difference was almost impossible to detect. You'd never feel it commuting to work empty. You absolutely felt it towing uphill in July. Fuel economy told a more complicated story than most people expect. You would think premium being more expensive should also deliver worse fuel economy since you're paying more per gallon regardless. But that's not actually how the physics works out. Truck B on premium averaged about 1.2 miles per gallon better across the full 200,000 mile test compared to Truck A on regular. That's because the engine could run more optimal ignition timing on premium, extracting more usable energy from each combustion cycle instead of retarding timing to prevent knock. More complete, more efficient combustion means better fuel economy. Even though premium itself doesn't contain more energy per gallon than regular, it's not that premium fuel burns hotter or has some magic ingredient. It's that the engine's computer can run it more aggressively without pulling back for safety. Once you actually calculate the cost difference over 200,000 miles, though, this is where things get interesting, and we will get to the real dollar figures near the end because the answer isn't as obvious as you would think. Now let's get into what actually happens inside these engines over that many miles, because this is where the test earns its value. We pulled both trucks in for a full teardown inspection at 100,000 miles and again at 200,000 miles, removing the intake manifolds, inspecting the intake valves with a bore scope, checking spark plug condition, and sending oil samples out for analysis at every major service interval. The intake valve carbon buildup told the clearest story of the entire test. Both trucks are direct injection, which means fuel sprays directly into the combustion chamber instead of over the intake valves like older port-injected engines. That design is great for power and efficiency, but it means there's no fuel washing over the valves to keep them clean, so carbon deposits from oil vapor and blow-by accumulate on the valve stems and valve faces over time on every direct injection engine, regardless of fuel type. At the 100,000-mile inspection, Truck A on regular showed noticeably heavier carbon buildup on the intake valves compared to Truck B on premium. We measured it using a simple visual scoring system our shop uses, rating deposits from 1 to 10 based on coverage and thickness. Truck A scored a 6 at 100,000 miles, Truck B scored a 4. By 200,000 miles, Truck A had progressed to an 8, showing deposits thick enough to visibly restrict airflow around the valve edges, while Truck B sat at a 6, still noticeable but considerably less severe. This isn't because premium fuel cleans valves better, it's because the more consistent, more complete combustion on premium produces less unburned residue in the exhaust gas recirculation and blow-by that eventually coats those valves. Less incomplete combustion means less raw material for carbon deposits to form from in the first place. That carbon difference actually showed up in real-world symptoms before we ever pulled the intake manifolds. Around 140,000 miles, Truck A developed a slightly rough idle and an occasional hesitation on cold starts that Truck B never showed. When we finally inspected the valves, that hesitation made complete sense. The airflow restriction from heavier carbon buildup was disrupting the air-fuel ratio at idle just enough to cause a subtle but noticeable rough patch. We ended up performing a walnut blasting induction service on Truck A at 150,000 miles to clean the valves, something Truck B never needed during the entire test. The turbochargers themselves held up well on both trucks, and this is honestly the part that surprised me the most going into this test. I expected premium to meaningfully extend turbo life given how much internet debate centers around boost and octane. What we actually found was that turbo bearing wear, measured through shaft play during teardown inspection, was nearly identical between the two trucks at both the 100,000 and 200,000 mile marks. The knock sensor system did its job, protecting the turbo on regular fuel just as effectively as Ford promised. The computer simply pulled boost and timing back enough under high load conditions on regular gas to keep cylinder pressures within a safe range, which meant the turbo itself never experienced conditions dramatically different between the two trucks. Both turbos showed normal expected wear for their mileage with no measurable difference in bearing play, no oil coking on the turbo housing, and no compressor wheel damage on either engine. Spark plug condition followed a similar pattern to the intake valves, but was less dramatic. At the 100,000 mile service interval, both sets of plugs looked reasonably similar, though Truck A's plugs showed slightly more carbon fouling on the electrode. By 200,000 miles at the second plug change, Truck A's plug showed a bit more wear consistent with running slightly retarded timing over a long period, but neither set showed abnormal wear patterns or premature failure. Both trucks made it to their scheduled plug replacement without a single misfire code logged on either vehicle, which tells you the knock sensor protection system genuinely does what Ford claims it does for basic engine protection. Oil analysis gave us some of the most objective data in the whole test. We sent samples out to a lab at every oil change and tracked wear metal content, specifically iron, aluminum, and copper, which indicate how much internal engine wear is happening between piston rings, cylinder walls, and bearings. Across the full 200,000 miles, Truck A on regular consistently ran 10 to 15% higher wear metal counts compared to Truck B on premium, though both trucks stayed within Ford's normal acceptable range throughout the entire test. Neither truck showed alarming wear trends, but the pattern was consistent enough across dozens of oil samples that it wasn't just noise in the data. The slightly less complete combustion and marginally higher cylinder pressures on regular fuel appear to translate into marginally accelerated wear on piston rings and cylinder walls, even though the knock sensor system prevents anything approaching dangerous levels. Transmission health stayed essentially identical between both trucks throughout the test, which makes sense since fuel octane has no direct relationship to transmission operation. Both trucks received the same fluid service intervals, and both showed comparable wear patterns at teardown, confirming that whatever differences we found were isolated to the engine itself and not bleeding into other systems. Now let's talk about the money, because this is ultimately what most people watching actually care about. Over 200,000 miles, assuming an average of 18 miles per gallon, combined for Truck A on regular and roughly 18.2 miles per gallon for Truck B on premium accounting for that efficiency difference we measured. Truck A consumed approximately 11,111 gallons of fuel, while Truck B consumed approximately 10,989 gallons. Using an average price difference of 60 cents per gallon between regular and premium over the multi-year test period, Truck A spent roughly $33,333 on fuel at an average regular price of $3 per gallon, while Truck B spent roughly $39,560 on fuel at an average premium price of $3.60 per gallon. That's a fuel cost difference of over $6,000 in favor of regular gas across 200,000 miles, even after accounting for the slightly better fuel economy on premium. But fuel cost isn't the whole equation. Truck A required that walnut blasting induction service at 150,000 miles that Truck B never needed, which ran about $350 at a shop rate. Truck A's spark plugs at the 200,000 mile mark also showed enough wear that we replaced them slightly earlier than we would have on Truck B, though this difference was minor, maybe $150 in accelerated maintenance costs. Even adding those maintenance differences together, Truck A still came out significantly cheaper to own over the full 200,000 mile test, with a total savings of somewhere around $5,500 compared to Truck B once you account for every fuel and maintenance dollar spent on both trucks. So here's the real answer, and it's more nuanced than either side of this argument usually admits online. If you're towing heavy loads regularly, especially in hot weather, or at higher elevations where the engine works hardest and knock sensor intervention is most aggressive, premium fuel gives you a genuine, measurable benefit in both power delivery and long-term engine cleanliness. The intake valve carbon difference alone is significant enough that if you plan to keep your EcoBoost past 150,000 miles, premium fuel meaningfully reduces the chance you'll need an induction service to fix a rough idle or hesitation. But if your truck spends most of its life commuting empty or lightly loaded, the knock sensor system does exactly what Ford engineered it to do, protecting your engine effectively on regular fuel while saving you real money at the pump. The turbo itself doesn't care which fuel you run, at least not over 200,000 miles of testing on these specific engines, which should put to rest a lot of the more dramatic claims you see in online forums about regular gas-destroying EcoBoost turbochargers. If you're the type of owner who tows often, drives in extreme heat, or just wants to squeeze every bit of performance and longevity out of your EcoBoost, the data from this test supports spending the extra money on premium. The intake valve carbon buildup difference is the single most convincing piece of evidence from the entire 200,000 miles because that's a real mechanical outcome with a real repair cost attached to it down the road. If you're a daily commuter who rarely tows and wants to minimize what you spend at the pump, regular fuel proved itself to be a safe, reliable choice that won't meaningfully shorten your engine's life within the range we tested. Ford built these engines with that flexibility on purpose, and after tearing down two identical trucks at 200,000 miles, I can tell you the engineering actually holds up. If you found this test valuable, go ahead and hit that like button and subscribe, because we've got more long-term EcoBoost comparisons coming, including a full test on synthetic oil intervals and how far you can realistically push them past the recommended mileage. Drop a comment telling me whether you run regular or premium in your EcoBoost, and let me know if there is a long-term test you want to see us run next. Thanks for watching, and I'll see you in the next one.